All right, I'm going to add on to our log and exponential functions notes here. And our overhead screen is lagging. Give me just a moment to get that figured out. All right, I think we have that figured out. So, and this is the process, looking up here, what we were just doing, thinking about things in log form and in exponential form. And so today, what we are going to do is apply that skill to solve some exponential equations. So in fact, I probably should more clearly state we're going to use logs to solve exponential equations. All right, so here's why we would want to or have to use a log. Let me give you an example where we don't have to. Before we started class, when you guys walked in, if I said, okay, 2 to the x equals 8, what does x equal? Well, x is 3, okay, because 2 to the third, 2 times 2 is 4, times 2 is 8, so x is equal to 3. So that is one where we do not have to use logs. That's because 8 is a nice number. If I said, well, I want to take 2 to some power to equal 50, that's not a nice number. Okay, the answer is not 25, by the way. It's saying 2 to what power is equal to 50? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. It doesn't fit nicely. It doesn't give us an integer answer. This is where logs come in. So on our Kahoot, we were working on changing this from exponential form to log form. And when we do that, remember, this becomes our base on the other side. So this written in log form could be x equals log base 2 of 50. So I converted it to log form. We're almost done. In fact, we did the hard part. That is the hard part. Now all we have to do is plug that into our calculator. So I'm going to use, I'll use the app first, and then I'll show the handheld in just a minute. But if you guys want to open your calculator app or take out your handheld, and if you hit the log button, which on the handheld is written in blue, you'll have to look for it a little bit. In fact, it is in blue in this column towards the left here above the 10 to the x. Okay. And on our app, if I did log, I had base 2 of 50. And I'm going to do, if I hit enter, it's just going to give me the same thing because that's an exact answer. I need the approximate. So remember on that, you click and hold down. It is approximately 5.6. That's rounded to the 10th, of course. So it's about 5.6.
Wait, how'd you get that like log 250?
Yep. All right. You're using the app, right?
Yeah.
So on the app, you know, in the third row down here, there is a log button. See that? And if you hold that up, then it's going to give you 2 boxes to fill in. So I just fill in 2 into the first box, and you can touch and fill in the 50 in the second box.
Okay. How did you get it though?
Like yeah, when you hit enter, don't just hit it, and you have to hit and hold enter. And then it should pop up a squiggly to the upper left. You want to hit the squiggle lines. That means approximate.
Well, I mean like the equation. How'd you get that from 2x equals?
I'm sorry, I got you.
That's okay.
Yeah, let's go back to here. So we are converting this from exponential form to log form. So remember, like what we were doing in the Kahoot, this moved over and became our base on the other side. So this is an exponential form, and it turns into this in log form. So you're just converting it from exponential form to log form. We'll do another one. In fact, we'll do a whole bunch. If we wanted to take 3 to some power, let's say 5x in this case. So 3 to the 5x power is equal to 100. All right, that's written in exponential form. So we have to convert that to log form. So when we do that, convert it to log form, the 3 is going to move over and become our base on the other side. So that in log form would be 5x is equal to log base 3 of 100. And so to solve for x, I'm going to have to divide both sides by 5. So I'm actually going to do log base 3 of 100 and then divide that by 5. So let's do that on our calculators. Log base 3 of 100 divided by 5. So I have log base 3 of 100. And then that whole thing is divided by 5. And I get 0.8 or 0.84 if it asks to round to the nearest hundredth. So be careful when you do your homework. So I'm going to round it to the hundredth and say that x is approximately 0.84. All right, any other questions yet? We doing okay? So that idea of converting is going to be important. I'm going to do a couple of problems that are a little bit harder. Okay, but we're still going to be following same rules of algebra and same conversion. So if we had something like 228 times 2 to the 3x is equal to 38. Now that's an ugly looking problem, but don't be intimidated by its ugliness. This is simple algebra rules and converting. So the first thing, if I want to solve this for x, I'm going to divide both sides by 228. So I have 2 to the 3x is equal to 38 over 228. I'm not even going to bother figuring that out because this is a total calculator problem. So now when I got this part by itself, I'm going to convert it into log form. So remember, this becomes our base on the other side. So I get 3x is equal to log base 2 of 38 over 228. And remember, I'm still trying to solve for x. So x is going to be all this stuff divided by 3. It's going to be log base 2 of 38 over 228 divided by 3. And here's where you thank your lucky stars they created calculators, right? That's what it's for. So I will do this one on the handheld. So I show a couple different examples. So on the handheld, I want to get to the blue log. So I'm going to hit Control Log. base 2. And in the parentheses, I have, whoops, that's not what I thought would happen. All right, let me do that again. All right, log base 2 of 38 over 228. So that's all one number, that whole big thing. And then I want to take all that and divide it by 3.
Mr. O'Connor, I can't see the calculator.
Oh, I'm sorry.
That's okay.
I have it up on the overhead here and I didn't change my screen at home. All right, so I did control log. So I have log base 2 of 38 divided by 228 and then divided by 3. And so then I have to hit control enter on the handheld. And I get negative 0.86. So kind of an algebraic extensive problem, but doable with the rules that we have. All right, any questions yet? I got one more before I'm gonna do a word problem with this. All right. Let's say we had this problem. Let's say 22 is equal to 500 times 0.5 to the x over 4. So that is our problem. 22 is equal to 500 times 0.5 to the x over 4. So the first thing we have to do is divide both sides by 500. But don't bother using your calculator till the end. So I have 22 over 500 is equal to 0.5 to the x over 4. Okay, if I'm going too quickly, please slow me down.
Wait, so we're trying to like separate the x wherever it
We're
is
trying to
from the
get
other.
this by itself. So
Oh,
first thing
okay.
we want to do is move this to the other side by dividing by 500. So that leaves just this on the right-hand side here. And now to get this out of that exponent to bring it down, I'm going to put it into log form, which means this is going to be my base on the other side. So that's going to be log base 0.5 of 22 over 500 is equal to x over 4. So to solve for x, I'd multiply both sides by 4 now. So I'm going to do 4 times log base 0.5 of 22 over 500 is equal to x. And this, we're just going to plug right into our calculator. So on the handheld, I'm going to do 4 log of 0.5 to the 22 over 500. I'll hit control enter. And I get 18.0. That will be rounded to the nearest tenth. So x is approximately 18.0. All right, any questions? We're doing okay? I mean, it looks ugly, but I think it's in our wheelhouse here.
Wait, Mr. O'Connor, so you divide the 22 by the 500 to get it wherever x is separate. And then you move what, like, let's say the x was the exponent. So you move whatever the regular number is into, like, I forgot what you call it, but like the lower part of the log.
Yep, and to the base of the log, right?
Okay. What if it was like in the parentheses, what if it was like 0.5 times 27 over 40? I don't know. Like it was more than just one number. Would you move all of that into like the lower part of the log? That makes sense?
Whatever that is to the exponent. So I think your question was like, I mean, if we had, if it was 27 times 0.5 to the x, something like this.
But the 27 and the 0.5 was like in one parenthesis.
If it's all in a
Or would it?
parenthesis, yes, then it would all be the base.
Okay.
Yep. Yeah,
And
you are getting
then
it. That's good. Any other
and
questions?
then whatever x is over, sorry.
That's okay.
Then we put that on the outside of log. Trying to figure this out.
Whatever this exponent is, that comes down, and that's going to be by itself.
Okay. Okay.
Okay.
Wait, I know like you move the 0.5, but why would it move down to a number like, oh, well, it's not an exponent anymore, right?
Right. It's now a base. It moves down and becomes a base.
Okay. And it wouldn't just stay as like, oh, well, no. Okay. So it turns into just like a regular number because like 1 to that as an exponent isn't an exponent anymore, if that makes sense.
Yes, it's not an exponent anymore. Yep. So like looking at the previous problem here, the 2 came down to be the base. Okay, that's here. And then this that was the exponent came down to be by itself. No longer an exponent.
Okay.
Okay.
Yeah.
All right. So now one application might be something like this. So there are.
Wait, could I screenshot it so I could write down the notes for the last problem?
The last problem. Yep.
Thank you. Got it.
All right. So there are 500 microbes in a petri dish. With a half-life of 4 hours. How long until 22 microbes are left? So there are 500 microbes in a petri dish with a half-life of 40 hours. We want to know how long until there's only 22 of them left. Okay, start with 500. Half of them die in 4 hours. Half more die in 4 hours. Half of those die in 4 hours. Okay. So our half-life formula, which is in our notes and it's up at the top, it says that our final amount equals our initial amount times 0.5 to the, I should have moved that down a little bit, 0.5 to the t over h, where h is the time of the half-life. So in this case, our final amount we want to be 22. Our initial amount is 500. We have 0.5 to the t over 4. And this is now a problem that we can solve. In fact, we just did. That's this problem. 22 equals 500 and 0.5 to the x over 4. So this is the work to solve this problem. Okay. So there would be, take about 18 hours. All right, I'm going to have you guys practice some on a class kick here for about 10 minutes.